Hi, in this video, I'm going to take you through the process of on how to implement the classification model on a data set. To download the data, open the Chrome. So I always prefer and recommend you to download the dummy data sets from the Kaggle. So go to Kaggle, click on hard disk data set. If in case if you are using the Kaggle for the first time, you may probably register yourself. This is like totally free of cost. Scroll down here under the data card option. You can see this download symbol. Click on this one. I as I already downloaded this file, so this is the pop-up that I'm getting. So click on download again. So the file has been downloaded. And also I always recommend you to use the Colab every time. I mean, of course, if you're comfortable with the Jupyter notebooks, you can go ahead, but I prefer the Colab. So Colab. So this is a Google product. Click on Welcome to Colab. So if you are using the Colab for the first time, you may probably have to enter your email address. So as I already have logged in, so this is the pop-up. I'm clicking on plus new notebook. If in case if you're using the Colab for the first time, I would like to give a demo. So I'm going to rename this as like first classification model. This is good. Click on connect, and here now you can see that we have connected this to the Google Cloud, and here on the left side there is a folder box. Click on that, upload the file, upload the one which you have downloaded. So the hard CSV, that's the file. Okay, let me do it again. Click on OK. You can see the status of the progress of uploading. Click on this one, copy path. So let's see. First one, import libraries, right? We need pandas as PD. We also need numpy for to find the blank values and all as NP. We also need we have to split the data. So we are going to use the sklearn libraries from sklearn dot model selection import train test split, and also we need random forest classifier dot ensemble import random forest classifier. I'm going to explain about each and every library in this video. So we have imported. First of all, let's import the data. Importing the data is the first one. So importing data here. I'm going to name it's a df, which is a data frame. So pd dot read. So we have the file in the CSV format, CSV. I'm going to update this one. If in case if you're dealing with like hundreds case of data and all, always give this low memory is equal to false. Of course, this is an optional one, right? So now click on. So let's see the first 5 records. Df dot head. Let's do some data exploratory. So for that, let's click on plus text. Let's do data exploratory. So basically, let's see like what kind of data we do have. So for example, if you wanna see the data types, df dot d data types. Let's see. We have all ints, and let's check whether we have any null values. So import numpy. Yeah, we already have imported this one. But if in case if you're using it for the first time, I would like it to be very clear. So df dot replace. Basically, if there are any blank cells, like blank cells I would like to replace with nan values, not a number. So in place is equal to true. Basically this helps us to save I mean, what this does is that this will find the blank values and it will replace with nan values, and then this will save here. And then df dot, is there any null values? Let's check. Dot sum. Click on this one. Oops, typos. And run this one. Yeah, this is cool actually. There are no null values, which is good. And let's see the info to see how many non-null values and how many records and all. Basically the difference between d types and info is that in the d types you can just get the data types of each and every column, whereas here you will get the values count, the non-values count, and also the data types. And also we can use one more if you want to see the list of columns. So just click on df.columns, which gives you the list of all the column names, which is good. If you want to see the mean values and the statistics, so df.describe, basically it helps you to give you all the values. For example, age, then the count of I mean how many records? 1025. What is the mean value? Mean value is nothing but the average value. Is a 54 is the average age of the people as per this data set. The standard deviation is 9.07, the minimum is 29, and the maximum is 77. So these are the ages actually. So now what we are going to do, so we have this data and all, and let's see whether this is a regression or this is a classification. So basically I mean let's quickly generate this one. Head, let's generate let's see the first 10 rows. If you look at the data, so these are all the columns: A, sex, CP, chest type, cholesterol, FBS, maximum heart rate, etc. So from age to THAL, these are the features. Features are nothing but the inputs. These are the inputs that we are going to feed to the ML, and this is the target value. So basically, we are going to feed all this data to the ML, and also we will, while feeding this data, we will train that. We'll tell to the ML that hey, for if the person age is 52 and the person sex is 1, which is a male, and the CP is 0 and all the target is 0. 0 means there is no heart attack, heart disease, and 1 means then the person may probably get the heart disease. So now before that, let's separate the features and the labels. Features are nothing but the inputs, and the labels are nothing but the columns. The targets. Click on code. So what I'm going to do, so separate the features and labels. Right. So x is equal to df dot drop columns is equal to, I'm just dropping this one because we are dropping the target column. So I have to put axis is equal to 1. Y is equal to df of, I'm just giving to the target, right? And now let's see the values of first 5 rows of x. You can see this is the data set without the output target, and let's see y of 5. So these are the output values. Now as we have the data, how many records we do have? So we do have a data set of df.shape, like 1025 rows and 14 columns. So basically what I'm going to do, I'm going to use 80% of this data out of 1025 for the training purpose, and the remaining once we develop the model, the remaining 20% I'm going to use this data to predict the new values and see like how accurately our ML model is performing. So first of all, before that, let's split the data into training and test set. Training and test sets, right? So for that reason, actually we have imported this model, train test split. This is the one which helps. So what we can do here, I mean I can write it again for you. sklearn dot model selection import prime test split, right? So x train, x test, y train, y test is equal to r prime test. If in case if you already have watched all of my other videos, I mean in the order wise, you might have you might have been comfortable with these lines of code by this time. So x comma y test size, I want it to be like 0.2, which means that 80% is for the training and the test data set is 20%. Random state is equal to 27. I mean if you update the same number, I mean the random state is nothing but if you want to repeat the same data values data set that I'm going to use, if you want to get the same values, just use the same number that I have updated here. You can update any value over here, which is like totally fine. Now let's execute this one and let's see xtrain dot shape comma x test dot shape. So here x train, I mean for the training we are going to use like 820 and the testing it is like 205. If in case if you want to see it mathematically, so we do have how many row, how many 1025, right? 1025 into 0.8. So if you look into this one, this is like 820, which is the training data, and 1025 into 0.2, which is 205, which is the testing purpose. Now we have done with the splitting data. Let's import our ML model. Start. Okay, ML model. So for that we are going to use from sklearn dot ensemble import random forest classifier. Why we are using the random forest classifier? Of course we have like so many models. If you go to this map, sklearn map, so basically choosing the right estimator, click on this one. Here if you scroll down you can see like there are like so many models actually. So we are looking at the classification. Why we are looking at the classification? Because if you remember our data set, so df dot head, so we have this target which is the output, right? Let's see the values, the unique values of this one. So df of target dot value counts. So basically this is like a discrete value, not a continuous value. So you can see like 1 0, it can be like 1 2 3 4 5 as well. I mean these are the classification, I mean these type of outputs we are going to use the classification models. Whereas for example if in case if you're predicting the rent of a house, or if you're predicting the price of a car and all, for those we have to use the regressors are basically for the continuous values and classifications are for the discrete values, right? So if you can see here there are like so many models. They are like linear SVC. I mean let's have a look at this one. So if we start from start, if it is greater than 50 samples, of course we have like 1025 samples, which is really good. If in case if it is no, we have to get more data. And yes, we are predicting a category. Yes, it can be like whether the person has heart disease or not. So predicting a category, yes. So the label data, yes. And then it should be no here. I don't know why it is yes here. Actually ideally it should be no here. Predicting a category, and then you can see the label data means like you have, you know, like what exactly the inputs and what exactly the output, right? Is it like less than 100k? I mean of course we don't have 100k records and all. So I mean this is how it starts, yes, no and all. So I'm directly going to use the random forest classifier at this moment and see. So what is random forest classifier? So random forest classifier, just assume that Okay, just assume that we have a forest and the forest has like so many trees, right? So that's exactly. So random forest classifier is nothing but this is like a forest of like many trees. You can see everything. So basically all of these we call as estimators, right? So we have like so many trees. So basically each and every tree it takes some data. It goes through the while developing the model. It goes through the tree and all, and it produces an output. So basically, whenever we try to predict the values, it takes all the cumulative average of all these trees, and then it predicts the values. So that's the reason this random forest classifier is one of the best methods whenever you are dealing with the classifier models. And also we have one more is which is the logistic one that I will walk you through in the other videos. So for now, let's go through this random forest classifier. So we have this classifier here, right? So I mean, instead of writing this random forest classifier every time, so I'm gonna write it like CLF classifier is equal to random forest classifier, which is really good. See, right now I'm not adding any values in this bracket. So there is one value which is which is a default value. N estimators is equal to 100. Whether you write this value as 100 or not, it's always like a default value. N estimators is equal to 100 is nothing but how many these trees we should consider. So I mean sometimes to increase this accuracy and all you may use like some 500 trees. Sometimes like 100 trees is fine. Sometimes like 90 trees is fine. So for at this moment I'm going with like 100 trees, which is the default value as this is the first video. So we have ran this successfully. So now CLF. So now what we have, what kind of data we do have, let's have a look at. So we have X train and we have Y train. So these are the data that we are going to feed the model. Then once after we train the model, so we have this testing data, right? So basically what I'm going to do, so feed to ML model here this data, right? And test use this data for testing. Now so how we are going to test is that we are going to use this X test and we are going to predict some values, and once the values we predict, we are going to compare it with these Y test values because we already have the Y test values. So CLF dot, let's fit the data. So X train comma Y train. Let's do this one. So it is done. CLF just to see this is like done. So I mean you get the same one. Now we have trained the values, and now let's see the score of the accuracy score. I mean, so CLF dot score for let's see for the training data. X train comma Y train. No, it is like 1.0, which is like 100% because this is the data that we have we fed to ML. So of course it is like 100%. Let's check the accuracy score for the testing data. Let's see how well it can predict for the test data which it hasn't seen as of now. It is also 1.0 because our data set is like very small, and also this is given like 100% accuracy. Let it be. Now let's start predicting the values. Predict values, right? So how we are going to do this one? So as like I said, we have this this X test, right? So I'm going to predict the values for the X test, and then I'm going to compare the prediction values with the Y test values, which is like the already values, I mean the original values. So I'm going to write it as like Y predictions, Y preds is equal to, our model name is CLF dot predict X test. So this is the new data, right? Y pred. So this is what it is predicted. For example, for first one, it has predicted like 1 0 1 0 1 1 dot. And now let's see what is our original values for this data, which is so to call this one np dot, let's call this an array, or else you will not get the same format. Y test. You can see this data as well. Let's compare this one and this one. Yes. So this one and this one, actually you can see over here. Let's see the score. I mean, so basically this is the score we wrote here, right? Instead of that, so actually we can use some other models like accuracy score. Um, so np dot mean. So let's just like y test comma y prediction values. Oops, okay, just ignore this one. So let's go with that. Let's check the accuracy score. I mean, either you can use like dot score, which we have done it before earlier, like this one, or also we can use the accuracy score library. So for that, so let's import a mod library from sklearn dot matrix import accuracy score. I know that you might be feeling like there are like so many libraries that we have to import and all. Believe me, that's how we have to learn this one. I mean, yeah, I mean, in one video, I'll make a video and I will list down all the libraries so that you can just copy all of those and keep it and refer them. So now print accuracy score of y test y threads. Yeah, this is like 100% actually. This is really good. And let's see. Okay. I mean, that's it. That's all for this video. So in the next upcoming video, so I'm going to tweak these n estimators instead of using this 100 n estimators. Let's see how it works if we have like 10 estimators and if we have like some 400 estimators. Believe me, if your system computational power, like in the sense of RAM and everything, if it is like really good, this works very faster. If in case if it is not good, it works like bit slow. So right now if you are using the Colab, so basically it allocates like some 13 GB of RAM around, which is like really good for this testing and for this like dummy data sets. Thank you and have a good learning.